Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem solving questions. It has 174 data sufficiency questions. We have already solved all of these problems. If you are interested in watching the original solutions to any one of these problems, you will find the original solutions from day number 1 through 250. Right now we are in the middle of redoing the problems and we are on page number 163. Please turn to it. Page number 163. The very first problem on the page there. The very first problem on the page, number 77. Problem number 77. Let's see what it has to say. It says, I'll tell you what, before we jump into the number 77 as it appears in the book, let's do a simpler version first. And once we understand the concept, it'll be much easier actually to tackle the problem that we have in front of us in the book in 77. Let's do a simpler question. Here's the problem. We are told that s equals 5 factorial plus 4. The question is then, in that case, then s is divisible by which of the following? And here are the answer choices. 3, 4, and 5. The question is, if we are told that s equals 5 factorial plus 4, then this quantity that you see here, 5 factorial plus 4, is going to be divisible by which of these three numbers? When we say divisible, we mean evenly divisible, either 3, 4, or 5. Let's find out. And you will see in a second, that's actually a very simple problem. 5 factorial plus 4, s is equal to 5 factorial plus 4 can be written as 5 times 4 times 3 times 2 plus a 4. Obviously, times 1, of course, there's no point in here. This is our s. Is this quantity divisible by 3? Let's find out. If we were to divide this quantity by 3, what we find is that this quantity that we see here, 5 times 4 times 3 times 2, is going to be evenly divisible by 3 because we see a factor of 3 on top and the bottom. But what about this 4? What about this 4? This 4 is not divisible by 3. We'll have a remainder of 1. So if you were to divide this quantity 5 factorial plus 4 by 3, we'll have a remainder of 1. This quantity is not divisible by 3. It is not divisible by 3. What about 5? Can we divide this quantity by 5? Can we divide this quantity by 5? Well, let's find out, shall we? 5 factorial is same as 5 times 4 times 3 times 2. And of course, we can divide that quantity by 5 very easily because we see a 5 on the top, we see 5 at the bottom, and it's divisible. Well, what about this quantity? 5 over 4 will be left there alone. 4 cannot be divided evenly into 5. So if you were to divide this quantity 5 factorial plus 4 by 5, what will end up is 4 times 3, which is 12, plus times 2 is 24. The answer will be 24 and 4/5. 24 and 4/5. This quantity is not divisible by 5. So you pretty much get the idea what's going on here. If you were to divide it by 4, well, there you go. Now 5 factorial plus 4 is divisible by 4 because 5 factorial is divisible by 4, and so is this guy. So now, if somebody asks you how much is 5 factorial plus 4 divided by 4, the answer is 5 factorial plus 4 divided by 4 equals 2 times 3 is 6, 6 times 5 is 30, 30 plus 1 is 31. So this quantity divided by 4 is just 31. It is evenly divisible by 4, but it wasn't divisible by 3 or a 5 because of the fact that we had this 4 sitting here by itself. Now let's do the problem that appears in the book. Instead of Now, of course, you can do the problem in the book yourself in a matter of seconds, in a jiffy. There is nothing in it. they call it n, and instead of 5 factorial they have 20 factorial, and they call it n, and instead of 4 they have 17. You see, they're trying to make it look intimidating. That's all it is. That's all it is. That's always the case. They're playing a mind game. Of course, you should not be surprised that they're playing a mind game, because that is, unfortunately, I'm sorry to have to tell you this thing. I'm sorry to have to be the one to inform you, but unfortunately, that is the bloody point. It's a mind game. What the hell did you expect it was? If you're taking an exam, they're just playing with you. They're just playing a mind game. By putting numbers like this, they make it look a little bit more intimidating. But the concept does not change. Concept stays the same. And the answer choices now that they give you is 15, 17, and 19. 15, 17, and 19. We have n, which is 20 factorial plus 17. 20 factorial, of course, is divisible by 15 very easily, because 15 will appear here, but you cannot divide 17 by 15. It's not divisible by 15. 20 factorial is also not divisible by 19. 20 factorial is divisible by 19. 20 factorial is divisible by 19, but 17 that you see there, odd one, is not divisible by 19. So, of course, this quantity is evenly divisible by 19, because 19 appears as one of the factors here. But you cannot divide 17 by 19. Therefore, 20 factorial plus 17 is not divisible by 19. It is not divisible by 19. But it is divisible by 17. But it is divisible by 17. It is divisible by 17 because 20 factorial can be divided evenly by 17, and this coin is just plus 1. That's all. So the answer, of course, as before, is 17. It's always a good idea. It's always a good idea in the exam. If they give you a very large number, or if they give you some intimidating number, sit down, stop there for a second, pause for a second, and ask yourself, can I make a simpler version of this question? Many a times we can actually capture the gist of the problem, the nub of the problem, the essence of the problem in a much simpler version. And if you can create a simpler version, then you're home free. Work through the simpler version, find out what the answer is, and the same logic, same thought, same concept would apply in the complicated version. Obviously, the answer is 17 only. Let's go to the next one, shall we? Let's go to the next problem. '78. In 78, we are given 3 faces as shown. Now, the reason I'm making such a big fuss about this part, the faces part, is because in the problem they do not use the word faces, they call them sides. I want you to know that a pure mathematician will have a fit. These are not called sides. What they're showing you here are not sides, these are called faces. This is one face. On the top here is another face, and here's another face. These are faces. Now, I do not like the way it came out, so I'm going to have to redo it. So otherwise it will bother me. These are called faces. These are not called sides. This is front face, this is side face, this is top face, and of course there are 3 more faces. It has 6 faces, not sides. Sides are these. Sides are these. These are sides. This is a side. And it's also called, sides are also sometimes called edges. Anyway, so that's what it is. There are 3 faces, and we are told that the areas of the 3 faces are 12, 15, and 20. The question simply is, what's the volume? What's the volume of this bloody thing? Let's find out, shall we? It's very straightforward. Just pick a number and put them in the side. See what happens. Let's call this a height. Let's call this the length, and let's call this the width. So let's start with 12. Let's start with 12 and just plug in anywhere you like. Let's pretend this is 4 and this is 3. So this is 4 by 3. That's one face. You see 12. The area of this face is 12. Now, if this is 4, then this side is going to be 4 as well. Let's give it a figure here. This 15 is not divisible by 4. 20 is divisible by 4. So let's put we have a 4 here, so let's put a 5 here. So we have a 4 times 5, that's your width. That's it, you're done. So that's 4 times 5, that's your width here. This is 4, this is 5, so this side is 5, and length is 3. This is our length, so this is 3 times 5. That's all it is. We were trying to figure out the dimensions of this box here, this rectangular box, and we just did that. The length is 3, the height is 4, and the width is 5. And therefore the volume that they're looking for is simply 3 times 4 times 5. Length times height times width. 3 times 4 is 12, and 12 times 5 is 60. The answer is 60. The volume of this thing is 60. 60 cubic unit. The 60 cubic unit. Whatever the unit happens to be, it has to be cubed, because it's unit times unit times unit. Is unit cubic unit. Cubic unit is the proper terminology. 60 cubic unit. Let's do the next one, shall we? What does this word mean? What does this word mean? Nub. Did we ever learn the word nub in our vocabulary lessons? No, let's find out, shall we? I'm going to look under my index card under N. Oh, there we go. Look, day number 11. Just type in GMAT vocabulary words. GMAT vocabulary words. Day 11. And the video will pop up where we learn the word nub, which means the gist of something, the essence of something, the core of something, the main idea, the main point of something. So what I said earlier, the way we used in the context this word was that, what we said was that if they give you a problem with weird numbers in it, like 20 factorial plus 17, make up a simpler version of it. And as long as you capture the gist, the essence, the nub of the question in the simpler version, then whatever logic that applies in the simpler version, whatever logic, whatever thought, whatever processes apply in the simpler version, the same exact things will apply in the more difficult version. Nothing changes. Math does not change, and you will have a pretty good idea as to what to do with the more complicated one once we know how to handle the simpler one, like we just did here. Anyway, this is it. Now listen, if you like, let's play a little game here. If somebody were to ask you, this is purely for fun, you understand? I know why you're here for. You cannot lie. I can read your mind. You're here to have fun. I know that. That's exactly this is a dream come true. You wanted some guy from God knows where to have some fun with in the math, so you found one. If somebody were to ask you, listen carefully, if somebody were to ask you to do this problem algebraically, not the way we did it in sort of a babyish way, but if somebody were to ask you to do this problem algebraically, would you be able to do it? Do you know how to do it algebraically? Let's do it, shall we? Let's do it on the top. It's very simple. Algebraically, what it is these are the three faces, 12, 15, and 20. So length times width is 20. It really doesn't matter what you call them. The notations, that really doesn't matter what they are. And length times height, let's call it, is length times height times width times height. And we are told that this is equal to length times width, width times height, height times length. We are told are 12 times 15 times 20, because you see these are the three faces, 12, 15 and 20. Those are the three faces, and that's what they give us. I hope I did not mess it up. I hope I did not muck it up. Okay, now what are you supposed to find here? We see a height here, like right here I see a height, and I see rather length, and I see a length. Length times length is length squared. I see a width, and I see a width, that's a width squared. I see a height and a height, that's height squared. And that quantity equals 12 times 15 times 20. Let's take a square root of both sides, shall we? Let's take a square root of this side and square root of this side. When we take a square root of both sides, what do we get here? The square root of L squared is simply L, W, and H. This is your volume. And that volume equals, I need the room, so we'll have to erase it, or we can do it here. This volume, length times width times height, now we know equals this kind. Square root of 12 times 15 times 20. 12 times 15 times 20. Well, we can write 12 as 4 times 3. This is our 12. We can write 15 as 3 times 5. This is our 15. And we can write 20 as 5 times 4. This is our 20. And now we have to take a square root of the whole thing. If we take the square root of the whole thing, we get 2 3's here. So square root of 3 times 3 is just 3. We see 2 5's here. Square root of 5 times 5 is 5. And then we see a 4 and a 4. The square root of 4 times 4 is 4. And there you have it. Length times width times height is same as before, right here. Same as before. 3 times 4 times 5. But that was more of an abstract way of doing it. It's more of an algebraic way of doing it. Let's go on to the next one, shall we? Enough of the geekiness for today. Let's move on. Number 79. Number 79. Just give me a break. Number 79. In number 79, we are told that we ran for 3¼ hours. Then we ran for 50 minutes exactly. 50 minutes more at 8 minutes per mile. The speed is very important. So what we did is, first we ran for 3¼ mile, that's it. However distance we ran for 3¼ mile, that's what we did. Then we decided to run for exactly 50 more minutes. We decided we only have 50 more minutes to learn, so we're going to learn for 50 minutes exactly. And our speed is 8 minutes for a mile. That's how long we're taking. We're taking 8 minutes to run 1 mile. The question is very simple. The question is this. How much further rather? How much further can we go and still be able to return to the starting point in exactly 50 minutes. In exactly 50 minutes. Now listen, before we actually solve the problem, I want to actually look at something in the book here. If Bob runs at a constant speed of 8 minutes per mile, interesting, very interesting. As I was writing it here, I made a boo-boo. There's a grammatical error. Can you tell me what grammatical error is there in this sentence? And if you cannot tell, pause the sentence and look at it closely. And as soon as I made that error, it bothered me. It hurt my eyes. And I was wondering if this is how they said in the book, and I doubted very much if this is how they would say it. These people who give you the exam, they do not butcher the English language as an average American does. I have a 10-year-old who was born in this country and therefore he considers himself native, I being an alien, and he always informs me that contrary to popular belief, the favorite American pastime is not a baseball, he tells me, it is to butcher the English language mercilessly. However, these people who give you the exam, they do not butcher the English language. I inadvertently butchered the language myself here. We should not be further. The correct term here is farther. Farther. How much farther? Far, farther, farthest. When one is describing a notion of distance, the proper word is not further, but farther. How much farther can we go and still be able to return to the starting point exactly? So here's what's going on. We started our jog here. We have run 3¼ miles already. And from that point, we decided we're going to run for exactly 50 more minutes. We're going to run, starting from here, we're going to run for exactly 50 more minutes. So let's say we ran X miles. And now we have to be able to come back all the way to our starting point. When we come back all the way to our starting point, let me redraw it, I don't like the way it came out. When we come back all the way to our starting point, we would go from x miles plus a 3/4 mile. So this is the amount of distance we have to cover. We have to cover x plus 3/4 and x miles in 50 minutes. That's all it is. That's all it is. And the question simply is, what's the value of x? How much more can I run? How many more miles can I run and still be able to come back to my starting point in exactly 50 minutes if I'm taking 8 minutes per mile? Let's do it, shall we? Enough of the talk, let's just do it. I need the room, I need a lot of room, so we're going to raise everything on the top. Just give me 1 second here. I think I'm going too much of a leisurely pace. I'm going a little bit of a leisurely pace, little bit lethargic because my throat is hurting a little bit. Anyway, so here's what's going on. So what we have to do is travel x plus 3/4 plus x. This is how many miles. We have to travel this many miles in 50 minutes. That's what's going on here. At 8 minutes per mile. This is our speed. 8 minutes per mile. Well, if we're going 8 minutes, if we're taking 8 minutes for 1 mile, that tells us that in 1 minute, we should be able to go 1/8 of a mile. 1/8 of a mile. But we do not have 1 minute, we have 50 minutes. Which means that in 50 minutes, we should be able to go 50 times this amount. 1/8 times 50, or 50 over 8 miles. There you go, that's it. And that 50 over 8 miles that we just found has to equal that quantity. And that's all it is. We equate the two and so we solve for x. That's all there is. Let's do it. I need the room, so I have to erase the bottom part here. We have to erase the picture. I don't really want to erase the picture, but there is no choice. There is no choice at all. Perhaps we can put it up here. So this quantity, 50 over 8, has to equal 3/4 plus 2x. You see, right here is the x and here is another x. 3/4 plus 2x. 3/4 can be written as 3 times 2 is 12 plus 1 is 13. 13 over 4 plus 2x. I need the room, so I have to erase this part. And that's equals to 50 over 8. The first thing I want to do is make the common denominator, have the same denominator everywhere. Let's multiply the top and bottom by 2 here, and let's multiply top and bottom by 8 here. So what we end up here, I'm going to rewrite it so it's legible. 50 over 8 equals 2 over 2 times 13 over 4 plus 2x times 8 over 8. That's it. That's all it is. Because 8 appears everywhere, it drops out, and we end up with 50 equals 2 times 13, that is 26, plus 2x plus 8 is 16x. 16x equals to 50 minus 26, which is 24. Let's continue here. 16x equals 24. 16x equals 24, and therefore x equals 24 over 16, which is same as 3 over 2, which is same as 1.5 miles. So the answer is we should be able to travel 1.5 miles this way and then back again 3/4 plus another 1.5 miles in exactly 50 minutes. That's all it is. Now listen, I have taken a very long time because I was going at a very leisurely pace. My intention was to do the next 3 problems on the same video, but obviously if we were to do that, the video will run very long. I'm going to stop right here. But listen, before I stop right here, I'm going to play with you a little bit. Can you tell me if this is the way you would actually try to solve the bloody thing in the exam? If you were taking the real exam, and if something like this popped up on the screen, is this really how you would solve this thing in the exam? I bloody well hope not. I bloody well hope not. This way is very geeky, very nerdy, very traditional, very orthodox, very classical, very algebraic, and therefore extremely, extremely time consuming. This is not how we take the exam. This was just to show you how much pain is involved if we were to do this way. This is not how we solve something like this. I'm going to show you now a quicker way, a simpler way to do this problem before we close the video. Would you like that? Listen to me carefully, okay? I need the room, obviously, as always. I'm running out of room, but you already got it, and of course you can always rewind. That's the beauty of the video here. It's not a classroom. So we're going to erase all of this thing, and I'm going to show you the simpler version. Here's a quick way. You see, in order for him to be, our story starts from here. Our story starts from here. The 50 minutes mark starts from here. The 50, he has to go this much and then back. He has to go. Now I'm writing everything down on the blackboard. That was my thought process that was going in my mind. Of course, in the real exam, I'm going to write everything down. I'm writing it for your sake. You understand? For your full benefit. He has to go 3¼ miles. 3¼ miles plus the X miles and the X mile. But let's first talk about the 3¼ mile. Okay, just listen to this. Very simple. 3¼ miles. We know that he's taking 8 minutes per mile. Well, if he's taking 8 minutes per mile, it should be quite obvious that the 3 miles should take 8 times 3. And the ¼ mile will take ¼ times 8, or 2 minutes. If you're taking 8 minutes for a mile, a quarter of a mile should take 2 minutes. 2 minutes plus the 24 minutes is 26 minutes. Keep listening, keep listening. So this part alone will take 26 minutes. We know that he has exactly 50 minutes. How much time extra does he have? This tells us that he has exactly 24 minutes left over. Well, if he has exactly 24 minutes left over, and if he's going 8 miles an hour, how many miles can he travel altogether? Well, 3 more miles. This implies that he can go 3 more miles. 3 more. This implies that he can go 3 more miles. And that 3 more miles, this 3 more miles is your 2x. Right here is the x, and the x on the way back. And therefore, x equals 1½ I'll see you tomorrow, okay? Bye now.